So this section is all about simplifying radicals. Now we've done some simplifying of radicals before, way back in chapter 1, but in these they're not going to come out evenly, right? So we're going to talk about how to solve those. So let's start off with example 1. We have the square root of 72. Now to do this, we're looking for pairs, right? The square root says we're looking for pairs of numbers that we can pull out. So we're going to do a factor tree for 72. So this is going to be 9 times 8. We do this as 3 and 3. 8 becomes 2 and 4. And then 4 becomes 2 and 2. So now we've got everything factored down. Like I said, we're looking for pairs that we can pull out. So let's circle our pairs. We have a pair of 3s and we have a pair of 2s. So we can pull a 3 out and we can pull a 2 out. But this 2 right there, that's going to have to be left inside. So this is going to be 3 times 2 times the square root of 2. Now we just simplify to finish the problem out. So 3 times 2 gives us 6 square root 2, and that's our final answer. Our next example is the square root of 20 x to the 4th y cubed. Now for this one, I'm not going to do a factor tree. I'm going to show you another way of solving this. We're going to look for the biggest perfect square that we can find for 20. So that's going to be 4 times 5, right? So we can take the square root of 4, that's going to be 2, but we're going to have to leave the 5 inside. Now I'm going to leave a little bit of space here for our variables. Now remember that our index, which is the number that's in the crook of the radical, that is 2 when we're dealing with square roots. So the next thing that we want to ask is how many times does 2 go into 4? Right? 2 goes into 4 2 times with no remainder, so we can pull out x squared. Now we're going to do the same thing for the y's. How many times does 2 go into 3? 2 goes into 3 one time with a remainder of 1, so we pull 1 y out, and we'll leave 1 y on the inside. And that's our answer. 2x squared y times the square root of 5y. For our last example, we have 2 radicals that are being multiplied by one another. Now since they do have the same index, an index of 3, we can multiply what's inside together. So we're going to call this the cube root of 9 times 21. Now we're going to factor these down as much as we can. So we're going to do the cube root of 3 times 3 times 3 times 7. Make sure that radical goes all the way up to the end of your problem whenever you're working on these. We're looking for sets of 3, and as you can see, we do have a set of 3 3's, so we can pull that out. So our final answer is going to be 3 times the cube root of 7. Alright, so that's all that we have for section 5.1. If you have any questions, make sure you post them in the discussion thread so that all the students can see them and the professor can respond. Have a great semester. Peace and love.